Today's topic is modeling equations, and the objective for today is I can use symbols and shapes to represent algebraic expressions. Now, I always kind of giggle when I teach this lesson because it kind of feels like a kindergarten lesson, because we're going to be dealing with triangles and squares, and it's going to seem a little bit silly, but believe it or not, every year there's a question like this on the OAA about whether or not you can represent algebra problems using shapes and symbols. And this is also kind of the way that you first learned how to do algebra, the way you were first introduced to algebra. So I think you've seen it before. We're not going to spend too long on it, but I do need to show you so that you're prepared for that question when it shows up on this year's OAA, because I'm sure it's going to. And it also gives you a different way to look at the math, which can sometimes be helpful. Okay, so we're going to start out talking about fruity math, okay? Fruity math. I have a banana and I have cherries. And what do you think the B represents in this expression? Well, that represents the bananas. And the C represents the cherries. So if I create just a little picture here, I have 1, 2, 3 bananas plus 1, 2, 3, 4, hang on, 5 cherries. I have 2 more bananas right here. And then I have, oh my goodness, 1, 2, 3, 4, 5, 6 cherries. Now, if I'm like a grocery store employee, perhaps, and I have all of these cherries and bananas, am I really going to organize them in the store like that? Well, no, that would be really silly. I'm going to take my bananas and put my bananas together, and I'm going to take my cherries and put my cherries together, because otherwise um, my grocery store is going to be it's going to be a disorganized mess. And that's just not how I want my grocery store to be. So if I look at what I've done, all I've done is really combined like terms. Oh, that sounds familiar, doesn't it? You talked about that when you talked about simplifying variable expressions. So how many bananas do I have now? Well, I have 5 bananas. And how many cherries do I have over here in this aisle? I have 3, 6, 9, 10, 11 cherries. So is that what we would get if we simplified this expression? Well, yeah, of course it is. If I have 3b plus 2b, that's going to give me 5b. And then I have 5c plus 6c, that gives me 11c. I have 5 bananas and 11 cherries. So that's one way you can use symbols or pictures to represent math that you're doing. And you might see something like this where they ask you to represent combining like terms using pictures that you would draw. Okay, that would be like one of the extended response questions on the OAA. You're familiar with those, the ones where they actually make you write things out instead of just a multiple choice? All right, so let's look at another example. This one is a little bit more abstract, and it deals with an equation. Now, I've been saying all week we're going to be solving equations next week, but this lesson gives you a preview of what we're going to be doing when we're solving equations. So I have 3x plus 2 equals 11. I'm going to use my triangles to represent my x and my little squares to represent one whole. Okay? So if I have 3x, I'm going to have 1, 2, 3 x's. And then how many little whole values do I have? I have 1, 2. So this kind of represents 3x plus 2. And in my equation I have, it's going to equal, oh gosh, I have to do 1, 2, 3, 4, 5, 6, 7, 8, almost there, 9, 10, and 11. Okay, so I have represented or modeled my equation using triangles and squares. And if I think about how I'm going to actually solve this problem, I have a square on this side and a square on that side, and actually those two squares cancel each other out. So I can get rid of those. I can put those in a little trash can. How about I make a trash can? That'll be fun. All right, there's my trash can. So I have those two squares in the trash can. I took one from each side, so it is still nice and balanced. I can do it again, though. I can take one from that side and one from that side and put them both in the trash can. And I still have a balanced equation. Now, if you see, I have one triangle, two triangles, three triangles, and I have 1, 2, 3, 4, 5, 6, 7, 8. Whoa, that was weird. Okay, that's just going to stay a rectangle. 7, 8, 9 little squares over on this side. And if I were to divide this equally, if I want to find out what just one x is, well, there are 3 yellow squares that go with every x. They divide up very nice and evenly so that each triangle represents 3 squares. And actually that tells me that 1x equals 3 whole numbers, or 3 squares, or the number 3. So this is a little introduction into how we model equations, and I'm just going to suggest that you rewind this video and rewatch what I did here with modeling the equation and then actually solving it, because it's going to be really important with what we do next week. And this video is only 6 minutes so far, so you do have time to go back and rewatch that. Don't just say you did, guys. Please go back, rewatch it. It's going to help you. Once you have rewatched it, I have a reflection for you. Your reflection: use triangles for x's and squares for constants to represent the following expression in your notebook. You don't have to do this reflection in Edmodo because you don't have squares and triangles that you can type in on your computer. But make sure that it's in your notebook when you come to class tomorrow. Notice this one does not have an equal sign, so it's a little bit different than the last one we did where we had an equal sign there. But all I want you to do is just take triangles and use them to represent x's and squares to represent each whole number. And I want to see what you can come up with in your notebook. Okay? So I can't wait to see those responses tomorrow. And have a great evening, guys. I will see you in class. Bye-bye.